Okay, I'm going to be solving the equation here. X squared equals 9x minus 27 over the set of complex numbers. Now when you do this, we're going to be using the quadratic formula for this particular example. But it is recommended that you move things to the side so that x squared will be positive. You don't have to do that, but most answer choices on multiple choice tests are written in a way that they move it to the x squared being positive side. So you may not find your exact answer if you don't do that. So to get everything to the same side, so that's equal to 0, with x squared being positive, I'll be subtracting 9x from both sides and adding 27 to both sides, which will give me, since nothing will combine there on the left, x squared minus 9x plus 27, and everything on the right is going to cancel out, leaving me with 0. Now, since we're going to be solving this with the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to know what a, b, and c are. And one thing I always recommend is it's not about the order. Don't say a is first, b is the second, and c is the third. That's not what it's about. When you're using quadratic formula, it's not letting me write that high. It is about how it's connected. So this is where the formula comes from. A is always beside x squared, or your variable squared. B is always beside x, and C is by itself. When you write it in standard form, A is first, B is second, and C is third, when it's in standard form. But if it's not in that order, then people often choose the wrong values for A, B, and C. It's not about the order, mind you, it's about how it's connected to the variable. So a is always the coefficient with x squared. In this case, there is no visible coefficient, so it's implied to be 1. B is always connected to x, in this case, negative 9, and C is connected, well, to no variable, it's by itself, so in this case, it's 27. Now that I have a, b, and c, we'll go ahead and substitute them into the quadratic formula. So we have negative b plus or minus the square root of b squared, so negative 9 squared minus 4 times a times c, which is 27, all over 2 times a, which is 1. Okay. Now, when I do quadratic formula, I always do the same 3 steps when simplifying. I find it helps me save mistakes, and when I do happen to make mistakes, it helps me find it a little bit easier. So the first thing I always do here is I deal with that there. Sometimes it's a double negative like it is in this case. Double negative makes it positive 9. The second thing I deal with is I type the stuff underneath the radical into the calculator. And the reason why I just do the stuff underneath the radical and not the radical itself is because there's a lot of times, depending on how the calculator works, the particular calculator that you're using can throw things off if you're not 100% sure on how it works. So it's better just to type the stuff underneath and then deal with the radical separately. On top of that, since I mainly teach Algebra 2, you won't usually be typing the radical into the calculator anyways. You'll have to break it down yourself, because it will either be a negative number or an irrational number. So if I type it in, forgot to change it back. There we go. So if I type the stuff underneath the radical into the calculator exactly as I wrote it, I get negative 27. And the final thing I always do is I type the stuff in the bottom of the fraction, which I usually don't actually type that part in, but I do go and get the answer for the bottom part. 2 times 1 is 2. So those are the 3 things I always do after setting it up. Next, I go through and deal with the radical. If it's a perfect square, it's dealt with differently, but most of the ones in Algebra 2 are not perfect squares when you have to use the quadratic formula. So I'm going to separate this. I know negative 1, it's negative, so I'm going to separate negative 1. It's 27, so 27 is not a perfect square. The biggest perfect square that goes into 27 is 9, and 27 is 9 times 3. So I'm separating it into negative 1 times 9 times 3, so that I can simplify my radical. When I go to simplify the radical, the square root of negative 1 is I, the square root of 9 is 3, and the square root of 3 we can't actually do, so the square root of 3 would just stay the square root of 3. There's one more thing you should check, and that's if you can reduce the fraction here. You can reduce it if something goes into all 3 of these numbers. Nothing goes into all 3 of them, so no, we cannot reduce this fraction. And the last reminder is that you can always write it out as 2 separate answers. This is the answer, but you can also write it as 9 plus 3i, radical 3 over 2, and 9 minus 3i, radical 3 over 2. This is an alternate way to write the answer.